The gut microbiome has emerged as a central regulator of metabolic health, and its disruption plays a critical role in the development of sugar-linked liver disease. Consumption of high-sugar beverages, including both traditional sweetened drinks and artificially sweetened diet options, can profoundly alter the composition and function of intestinal bacteria, triggering a cascade of metabolic events that ultimately stress the liver and promote fat accumulation. While the liver is often viewed as the primary site of metabolic regulation, the gut acts as an essential mediator. When its ecosystem is disturbed, the liver bears the consequences, making the gut-liver axis a key, yet often overlooked, pathway in the pathogenesis of non-alcoholic fatty liver disease, NEFLD. Excess sugar in beverages serves as a readily available energy source for certain gut bacteria, selectively promoting the growth of species that thrive on simple carbohydrates while suppressing populations of beneficial microbes. This imbalance, or dysbiosis, is not just a benign shift in bacterial populations. It directly increases intestinal permeability, sometimes referred to as a leaky gut. When the gut barrier is compromised, bacterial endotoxins, such as lipopolysaccharides, LPS, pass into the portal circulation and reach the liver in high concentrations. Once in the liver, these endotoxins trigger inflammatory signaling pathways in hepatocytes, activating Kupffer cells and stellate cells, which in turn promote fat deposition, oxidative stress, and fibrosis. This process provides a mechanistic explanation for why excessive sugar intake, even in liquid form, can silently and progressively contribute to NEFLD, independent of total caloric intake or body weight. Diet sodas, often assumed to be harmless because they are calorie-free, are not exempt from this risk. Artificial sweeteners like aspartame, sucralose, and saccharin disrupt the gut microbiota in ways that are distinct but equally harmful. Studies have shown that these compounds reduce microbial diversity, alter the abundance of key bacterial families, and impair metabolic signaling in the gut. These changes can mimic the effects of high-sugar diets, increasing intestinal permeability and promoting low-grade systemic inflammation. When combined with other dietary stressors, such as refined carbohydrates or processed foods, diet sodas can indirectly accelerate hepatic fat accumulation, insulin resistance, and the early stages of liver disease. The consequences of microbiome disruption are amplified by the liver's role as the body's primary detoxification organ. The liver is continuously exposed to metabolic byproducts, toxins, and bacterial endotoxins delivered from the gut. Chronic exposure to LPS and other inflammatory signals from a dysbiotic gut increases oxidative stress in hepatocytes, impairs fatty acid oxidation, and enhances triglyceride synthesis. Over time, this creates an environment where fat accumulates, inflammatory signaling persists, and the liver's ability to respond to additional metabolic challenges is diminished. Because early NEFLD is largely asymptomatic, these changes can progress silently for years, leaving individuals unaware of significant hepatic stress until advanced disease has developed. The implications of sugar and diet-induced microbiome disruption are particularly concerning in adolescents and young adults, whose dietary habits often include high volumes of sweetened beverages. Early life alterations in gut microbiota can have long-lasting effects, programming metabolic pathways toward insulin resistance, fat deposition, and chronic inflammation. Repeated exposure to sugar and artificial sweeteners during critical developmental windows may predispose the liver to early-onset NEFLD, increasing lifetime risk for metabolic syndrome, cardiovascular disease, and other comorbidities. Mitigating this risk requires a twofold approach: reducing intake of both sugary and artificially sweetened beverages, and supporting a healthy, diverse gut microbiome through diet. Whole foods rich in fiber, polyphenol, and prebiotic compounds promote beneficial bacterial populations, strengthen the gut barrier, and reduce the translocation of endotoxins to the liver. Fermented foods and probiotics may also help restore microbial balance, although their effects are often transient, without concurrent dietary changes. Water, unsweetened teas, and minimally processed foods allow the liver to operate without chronic inflammatory stress from the gut, highlighting the importance of beverage choice in overall hepatic health. In short, the gut microbiome acts as a powerful intermediary in sugar-linked liver disease. Both high-sugar and artificially sweetened beverages can disturb this delicate ecosystem, increasing intestinal permeability, triggering systemic inflammation, and promoting fat accumulation in the liver. The indirect yet potent influence of the gut underscores why beverage choices that seem calorie-free or harmless may in fact carry serious long-term consequences for liver health. Protecting the microbiome through careful dietary selection is therefore not just beneficial for digestion, it is essential for preventing the silent, progressive damage that underlies NAFLD and related metabolic disorders.